This means that in the time domain, your period of sampling is too dense, too small, right? So it could mean that in the time domain, suppose this is your analog signal, okay? Suppose that's x of t. When you're sampling over sampling by 2, what happens? It means that your sampling period is too dense, too small. It means that you have too many samples. Okay? Too many samples. That's what it means. How do I fix it? How do I get critical sampling from this signal? Well, suppose you don't know this. How do I do it? Right? Let me erase this, okay? Suppose you have no idea what multi-rate signal processing is. You have no idea what this is. You have not learned this class yet. If you want to go from here to that, what do you do? That's what is x prime, that's x. Erase it. Okay? Is that clear? You come back and you give me this spectrum. I said this is not good enough. You are wasting the spectrum. You're not using the high frequency spectrum. Go back and do it again. So tell me how you do it. How to go from x to x prime.
I think we can return the even sample and remove the odd sample.
You don't know this yet.
Okay? I don't know that.
That's a shortcut.
I see this figure.
Okay, good. So that's the solution. But what you could do is you could take x of n, right? You recover, you got x of t, and you sample again. That's the solution. You have no idea what this means so far, right? So the conventional way of doing this is reconstruct your analog signal x of t and then sample again. Right? Sample. So this is period t. What is the sample here? Sample and reconstruct. I know this is not a good solution. Okay? What is that period? 2t. What we're saying here is oversampling by 2. It's too small. You can make it bigger. By 2, make it by 2. This is 2t. And you got that. What's the problem of this particular way to do this? What's the problem? It's analog, right? So you have inaccuracy. Okay, so a lot of problem here is this second distortion effect of the sampling and so on and so forth. But the easiest way to do this is take x of n and do what? Now by 2 and times 2, right? This is 1/2, okay? So it's by 2. That's what you do. Okay? So multi-signal processing allows you to manipulate digital signal. And this operation is manipulating change the rate. And that's basically tied to sampling curve in this sense. If you're sampling too fast, you can change the rate by doing this. Now, the complication here is that if you're sampling too fast by 3/2, then you have to combine up sampling and down sampling. You got 3/2. Okay? So, any question on this so far? So I'm going to discuss the next thing about estimation. Any questions? So suppose you have a signal that looks like this. I want to give you a problem, okay? What happens when we downsample by 2? You have aliasing, that's a big problem. So I'm going to do another step. What do I have to do before downsampling by 2? If I have a signal that's not banded to pi by 2. Filter first, right? So before it's down by 2, I have to filter first. Is that clear? What does that filter look like? That's be low pass filter or pi by 2, right? Because I know that this has to be band limited to pi by 2, right? This is not. So my filter have to be somewhat, ideal low pass filter or pi by 2, right? So I know that after going through a filter, what happens is that I'm saving that part, right? After downsampling, I got this. Okay? So the output will look like there's no aliasing, right? But I'm only retaining the low pass part. Is that clear? How do I save the other part? Use a high pass filter. What if I do this? H prime, which is the high pass filter. Right? Does the H prime look like, okay, this? Ideal high pass filters. What happened? Over here, I'm saving this part. Right? So the spectrum of this signal right there is what? It's this. This is pi by 2, 3 pi by 4. Right? And if I downsample by 2, what's the output look like? Where does pi by 2 mark to?
So
Pi and 3 pi by 2. Alright, so pi, 2 pi, 3 pi by 2. And the other one on the side. Sorry. Minus 3 pi. Is that it? No. We deduct the output of this operation. If the input is this, what else do you need? You need this spectrum shifted by 2 pi. Okay? So pi shifted by 2 pi, where does it go? 3 pi. What does 3 pi go to? What is 3 pi? It's minus pi. So how do I draw this? Right. I'm taking this one, okay, shifted by 3 pi. It's wrapped around and going back to here. I do the same thing here and go over there. Okay? So you see that